last sections, that we in all these AI agents have this large language model as their core, right? So AI agent is a system whose control flow is defined by these large language models, right? So we have a start, which is the input or the prompt, and then there is a step in between, whether we are taking in input from a form, which is also called trigger, right? So, and this large language model, it uses this trigger to follow certain steps. So let's say that if the review is positive, it will follow certain step. If the review is negative, it will follow certain step. And if the review is neutral, it will follow certain step, right? And it will make a decision and classify these three, and then do certain things, whatever we want them on each step. And we also discussed about types of agents, and we have these router agents, which use LLMs to route to certain steps, where we are defining these steps. And there are fully autonomous agents which also define what steps that they want to follow. And this we discussed in our class 2. And we also know that the higher the reliability, if we want more reliability, then we will have to give the router agents less control. And if we want more control of the agent, like that means that the agent controls the flow, then our reliability will be really less. So how to control this, and what is the best framework to give the best case scenario in this, is that we use something called LangGraphs. And these LangGraphs have been these open source agent building tools that have been prepared by these MIT research labs, and they have made these for everyone to use in their systems to build certain agents. So what LangGraph does is it gives the agent a higher level of control, also maintaining reliability. So what it does is it provides this graph type of structure in which you code, and you build the agent around that. So whatever we did in relay, uh, in a drag and drop manner, the similar kind of like graph, or kind of like a flow structure or a workflow, we will design with coding in a very intuitive way. That means that not very much skill is required to build or to code. Although you can code these LangGraphs using any of the AI tool also, like ChatGPT, Gemini and all. If you can tell your problem to ChatGPT, Gemini in a very particular way, they will be able to write the code for you. But the idea of today's class is not to write the code, but to understand between the lines of the code and what the code means, so that whenever you have these AI generated code, you are always ready to debug them, right? So what LangGraph does is it introduces these graphs and chain, which have a start or a trigger from where we will start our graph. And then we have these nodes which act as these decision makers, or the brain of or the steps of this graph. So let's say that we have a start, and then we have a large language model as a node which classifies these reviews as positive, negative and neutral. And then we have subsequent nodes after that, just like we did with relay, right? So we have a start or a trigger node, and then we add a large language model, and then we add more nodes according to the steps that we have in the process. And this large language model, it acts as a brain of this whole agent, right? So we are using this agentic AI architecture called LangGraphs, and we use this large language model to decide which way to go or which route to take. And the good thing about LangGraph is that it has these qualities of persistence. It has a human in the loop. If you want to make decisions more controlled by keeping a human to to check in between, then you can also have those capabilities, and it also is controllable. So LangGraph provides this controllability also. So if instead of designing these like router agents, where you can also design by if and else statements, we are using LangGraphs, which will give us more control over our flow, including persistent streaming, human in the loop, and controllability in there. Sorry, my screen share is. All right. So what is a LangGraph? So you are saying that, okay, you are talking about LangGraphs, and we will be designing all these agents using LangGraphs. So what is a LangGraph? So LangGraph is a framework built by MIT students and researchers for building stateful multi-step AI workflows and AI agents. Think of it like a flow chart where each step is powered by a large language model or a language model like ChatGPT or Gemini. It's built on LangChain. LangChain was the previous version, which used to have a linear type of flow, but it also adds the ability to manage loop, memory, and state. So this we will see when we will implement it on the ground. And it is also visual. That means that it will also give you a flowchart diagram with nodes and arrows. Okay, so in LangGraph you can build this type of graphs also. To use LangGraph, why use LangGraph? Because it has a memory, so it keeps the track of information across steps. So if in step 1 you are giving some information, so let's say that you are taking the information from a form, so it keeps that information from the form with itself, and that passes that information to the other state, which can be a large language model, to decide whether the review is positive, negative, and neutral. And whatever the large language model decides, it keeps that information to use in the next step in this graph. It also supports loop. So it also supports like retrying or going back if a step fails. So let's say that if a large language model is not able to classify this review into positive, negative, and neutral, so it will fall back to step 1 where it is getting this review. It also is flexible because we can choose different paths based on model output, and it has better control, or we can build better than basic chains for complex workflows. We can have more control with LangGraphs. So some of the key concepts which I will talk about along the way is one, which is a node. So a node is a step or a function in the flow. So let's say that if I add a so let's say my trigger node is when I'm adding any review on my flow, on my form, right? That's what we designed in our last masterclass, last to last masterclass. So let's say that form is one node. So one node will be the input node, right? So and then there will be one node which is the large language model or chat GPT node, or a Gemini node, whatever node that we want to use. And then there will be a edge or a connection from one node to other. So one node to other, we will call that an edge. That edge will pass on information. It will also have the definition of which nodes it is being connected with. There is a graph state, which is a shared memory across steps. So we use a state which stores this memory across steps, and it stores like variables and the values of whatever these steps or nodes have generated. And then it has these events which will be triggers for moving to the next node. So let's say that in our example, so if the review is positive, it will move to the next node. If the review is negative, it will move to another node. And if the review is neutral, then it will move to other node, right? All right, so there are some questions which I will read before I move further. So Aditya is saying, will we require a code in today's session? Yes, we will require. And Atish is saying that my YouTube link is not working. So my team is working on that, and they will let you know when the link is live. Pranjali asking, what is the difference between LangGraphs and LangChains? So LangChains are kind of like a chain architecture, which I already might have explained in this. So one way of designing our agents is to have a stepwise flow, which has these steps: step 1, step 2, step 3, and all. And these are the invocation steps. And this is kind of like a chain type of architecture, where let's say that after one step we are going to another step without taking care of what has been done in the first step, right? So we might have some output that we are moving, but we are not keeping these states in mind. What is the state of that node? So what LangGraph do is they also have this memory of what node was being invoked and what was the state of that node. And that's the main difference. And that's what makes LangGraphs more powerful than LangChains. So LangChain versus LangGraph, I also have explained in my slides. So if you talk about feature, then LangChain have basic memory. LangGraphs have stateful or the global memory. So it has states which is stores in a global memory, and it retrieves these states from this global memory. In LangChain, the loops are not easy because it's kind of like a single structure, and in LangGraphs, the loops are built in. So if a node is not being active, then what it does is it automatically loops it back to the node previous to that. In LangChain, the branching logic is limited. In LangGraph, it is very flexible. And LangChain is best for simple chains, and LangGraph is best for complex workflows. So if you want to design these complex workflows where you have a lot of decision making to be done, then LangGraphs is one of the powerful and the state of the art method to design these complex workflows where we use large language models as decision makers. And that's kind of like the basic difference between LangChain and LangGraph. So if you want to design like simple agents, like chain agents, like I don't know if we designed a simple tweet generator or not in our first session when we started with simple reflex agents. Then we designed a tweet generator, right? So that kind of system you can design with LangChains, but for more complex kind of like workflows where you are designing, let's say, a personal assistant for your own, or a medical bot where you are classifying the person's response into a emotional or a mental one or a general one, or maybe let's say some other response, and then correspondingly sending it to those medical wings. So let's say that you want to design an agent for a hospital where you are classifying the patient's inquiry into different kind of categories, and then in these different kind of categories it is doing certain steps. So let's say that it is calling a doctor, or it is calling a consultant, or whatever is required. So this is what we will build in today's class: a real case study uh, of a agent which we will use for medical purposes, and we will use this. Suppose a user is interacting with this agent and he's telling this agent about his inquiry. So let's say that I have a fever, and I have this medical agent which understands the disease that I am having, and it gives it kind of like classifies me into a category in which I should go and check, and then there can be multiple steps. So let's start coding, and I have given an idea. So what we will do is I'll just describe it here also, and uh, what I will do is, so let's so what we will have is we have a start node which we will interact with, and this start node. So we are designing a medical bot which classifies my queries. So it asks a user what problem that they are facing, and it classifies these queries into different categories in medical. So let's say that if the person has a mental health issue, then it classifies it into a mental health issue and send it to the proper ward. So let's say that there is a mental health issue ward in a hospital. There are different wards. So we have an inquiry. So this step is an inquiry step. Let me call it inquiry. And then it is sending this inquiry to a router. Okay, so this is a router, and this router is what it is doing is it is classifying the inquiry based on yeah. This router is classifying this inquiry on the base of uh, 3 inquiries. So let's say that my hospital has these 3 wings. One is a general purpose wing, or so let's say there is a general purpose wing, and then there is let's say a mental health wing, and then let's say there is uh, emergency wing. Okay, not accident. So let's say that emergency wing. So I'm designing an agent for a hospital where a person who is coming, or let's say that there is a problem in the hospitals, right? So a person doesn't get treatment immediately because there are many processes to follow. So let's say that you identify that problem in a hospital and you want to design an agent that solves this problem. So a person enters the hospital, he tells this, so he has this kiosk instead of a person sitting there. So multiple kiosk. He goes to a kiosk and the kiosk asks what the inquiry is. So let's say that I say that I'm suffering from fever. And this what this mental health this agent does is it uses a router. It understands my query. So let's say that if I am using a voice-based assistant, and I will do a text-to-speech or speech-to-text version, and my large language model understands what the user is saying, right? What he is describing. So if he is describing that my body is hot and I am experiencing these chills, I did not sleep yesterday, and I'm experiencing this fever. So on the base of this inquiry, what this router does is it categorizes it to a general category, mental health or emergency. And it says that, okay, your category is general. That means that you will see a physician. Please enter these details. And then after general, it can follow these steps, whatever steps are there. So let's say that book an appointment and then go to the doctor. If it is mental health, then book an appointment with a psychiatrist, or if it is a consultant. If it is an emergency, then fast forward it to the emergency ward. So whatever is the process there, right? So it can be so this is the kind of agent that we are designing today. So similar to what we designed last time, a classifier agent. And but what we are going to do is not using relay. So let's say that why not using relay? Because we want, let's say the a hospital has more safety issues and they don't want to give their data to any third party. So let's say that they don't want to give their data of a person or a patient to another third party. They want it to keep as secret, right? This is main concern of a hospital, that they don't want their data to go out. So let's design this, and we will start coding and designing it in Colab. So what we will do is I will just share a link of Colab with you so that you will be able to also design the same. I'll just close this annotations, and I'll go back to uh, browser, and so clear our drawings and close this. So let me just share you with a template of the coding so that we all have the step-by-step process. All right, I have designed this for you. So I'll just share this. I'll search for LangGraphs, and I hope that I am in the right account. All right, let me just check. All right, till I find my collab link, I'll just keep the slide blank so that I can put in my credentials. And let just give me a time so that I can share you a link which will help us to follow a structure. I would have started with an empty notebook, but that would not help us in any case. So I have designed a structure for you so that you can follow, just like we did last time, right? When we were designing these tweet generator. All right, so I have got the link. I am pasting this link on the chat. What I need help from you is once you have uh, gone to the link, just let me know in the chat if you were able to make a copy of it and save it with your name. Okay, so what you have to do is go to the link and which I have pasted in the chat box and go to the link. All right, so I'll just share my screen where I also go to the link, and what we will do is we will make a copy of this. Okay. So make a copy of this because this is just a read-only file. So save a copy of this in Drive and change this my to your name. Okay. So open a new tab and change this copy of my LangGraph to your name. Okay. So let's say my name is Amit and I'm naming it like Amit my LangGraph.ipynb. All right. So first, we will begin with installing some dependencies. That means that we will have to install some libraries. So why I'm using Colab? It's better to do it in a in a virtual environment in your own PC. Why I'm using Colab is that because we could share our resources and I could do it live. Otherwise, I would just have to explain the code, and you would have to install these dependencies. And not everyone has these coding or IDEs set up in their PCs, right? So some of you are also from non-tech background. So I just want to avoid that. And we will start with installing some dependencies, and then we will import and secure this API key. We will secure this API, Gemini API key input. Last time what I did was I put it there, and I don't want to do that. Initialize this Gemini 1.5 flash, and we will ask a node, we will make a node to ask user for symptom. So this is our input or the user interface, and we will ask it to classify the symptom, and we will put a router logic to route to the correct node. We'll categorize a specific response node, and we will build this LangGraph and compile and invoke the graph. So for the next 1 hour, we will do this exercise um, uh, uh, coding. Okay, so we will code this from scratch, try to understand what the code is and what it is doing, and in the process, learn this graph structure, right? So I also am keeping these annotations to show what the flow looks like. Okay, so we will have a start node, and in this we want input, right? So a person goes to a hospital and he puts in its input, like so let's say that he goes to a kiosk screen and he types in its symptoms, whatever the symptoms are, whether they are in an accident or whatever has happened with them. So they will type in these symptoms. Okay, so we will define this input node, and then we will keep on building this graph, and we will also see how the graph looks like on LangChain. All right, so if you have renamed this file and if you are ready to code, in the chat box, let me know with a yes or a done. And I already have got many responses. um, Thank you so much, Shraddha and Daksh. Thank you so much, Jeel, for responding. Thank you, Aditya, Aman, and Jay, and Dhruvi, and all those people. Let's begin coding, right? So a lot of people are saying to explain LangGraphs and LangChain more. So I would urge you to go to the LangChain and LangGraph tutorial, which are already there. They are very beautiful and very much Meet is saying ready to fire up. And I like the energy. I like the enthusiasm. Um, yes, Amit is saying, Khushi is saying that, sir, there is a problem with this, that in this we don't have to put more questions so the person doesn't get irritated. Yeah, so we can keep things very simple. That's called user experience. So the better the user experience will be, so that we can keep it more simpler, right? So let's see how we design our graph. Okay. So first thing that we will do is we will import these libraries. We will install these dependencies. Okay, so I have made this code specifically fit this Gemini API. So we will have two imports, install certain libraries from Google and certain versions of it. Okay, so it doesn't work with all the versions with Gemini. So I had to like code, recode, decode a lot to fit the free version of Gemini. Otherwise, you can do it very easily with ChatGPT. A lot of AI generated code will tell you that. And that's why we are not generating this code with AI. I am not using ChatGPT to say, okay, generate me AI agent which classifies my input into three categories, and then it will write me a code. But that code will be buggy. And that's why I am emphasizing on writing our own code today, so that we understand each line of code. And then whenever we are writing this code with AI also, then we are good to go with the code, because we understand where the error is, right? And then we can change the code according to how we want it to behave. And that's the whole exercise about. And you will be saying that, sir, writing code is like so past, right? Because nowadays, who writes code? We use AI to write the code. But today in this class, we will write it because we want to learn what is there in the code. And in practice, we will always ask the AI to write the code, or to assist it, or to use it as a co-pilot, or to use it as a co-assistant or co-coder, right? Thank you so much. I have got more than 40 responses of saying yes. That means that we are good to go. So we'll install these dependencies. We will use pip, and we will use apostrophe before, because we are using this collab environment. So I will say pip install, and I will install this. So I'm installing these versions only, right? So I will install this first version, which is Google dash generate and generative API AI, and I will use this version 0.8.5. Okay, so I will install this Google generative AI. This is what we did that day also, right? So we want to use Google's generative AI, so I will have to install its library or its packages into my environment, and I will use 0.8.5. This is what I have um, um, uh, discovered, that it works very well with the collab environment. Otherwise, if we were using let's say Jupyter notebook or a local environment, we would not be requiring to even define the correct type of um, we would be using the latest one. And this is also particularly helpful when we are creating or deploying this on cloud. So let's say that we are using AWS, or let's say that we are using whatever tools that we want, let's say render, or uh, any other tool to deploy our backend. Railway is also one platform. Then it's always good to define what type of version that you are using, so that the compatibility issues are not there. All right, so I will give it a definite value, equals, and define it properly. So pip install google.generative AI, which is the version 0.8.5, and also the language part of it. So google dash AI dash generative and language, and the version would be 0.6.15. Okay, so if we were not doing it on collab, I would be just be happy with um, just these two files, Google Generative AI and Google AI Generative Language. I am defining these versions because of the compatibility issues. Okay. And then we also want to install LangGraphs. Okay. And what I will do is I will just write it in the next line. So I can just give it like this, and LangGraph, because we want to use LangGraph, LangChain, because it inherits these LangGraph is built upon LangChain, so we also need LangChain in this. And then LangChain dash Google dash Gen AI. So LangChain's version that works with Google. Okay. And yeah, so if you want to use OpenAI, you can also import OpenAI in this, but that is not needed right now because we will be using Google's Gen AI, right? But let's just keep it so that we are ready to work with any of the large language models. So those people, those who have like OpenAI's API, they can use OpenAI. Those who have Google's Gen AI, they can use Google's Gen AI. All right. And I will just run this. Okay, it will take some time to connect to my environment and it will just run this file. And so these are the libraries that I'm using: Google's Generative AI and LangGraph, LangChain, LangChain's Google Gen AI model, and then also uh, importing this, installing this OpenAI package. Okay, so if it is ready, then give me a thumbs up or say yes or done in the chat box so that I can move to the second step, which is very important, to import and secure this API key input. Okay, so we want to import and secure this API key input, which we will get in a while from Google's developer account. Okay. Meet is saying that, yep, all done. Dhruvi is also ready. And Aditya is reading. So if you are doing it on local machine, what you will have to do is you will have to define all these packages and you have to create a virtual environment and install all these packages. Those who know programming, that will be for those guys. And if you're deploying it live, then you will have to you will have to use a file called requirements.txt. So you define all these packages in that requirements.txt file, and then you uh, kind of like make it live. So you in your packages you have this requirements.txt which you install uh, in your environment or whatever you, if you are doing it on render, then you will build using these requirements.txt files. So basically you are creating your own virtual environment with those requirements. So you'll have to set these kind of libraries to install. That was purely for people who are from coding background. If you are not from coding background, that the simple thing is that you just have to install these packages in order to use them in our code, right? LangGraph use karenge, to LangGraph we have. LangChain use karenge, so we are importing LangChain. We are using Google's generative AI, so we are importing that. Why Google's generative AI? So that you all can code. Otherwise, you all will not have OpenAI's API, right? All right, Param says good to go, and I think we are. So let's go to step 2, which is to import and secure my API key. Okay, API key input. So in our last class, what we did was I pasted the code directly there in order to make the process a little faster. But we don't do it in production. So if you are making your own agent, then you don't want to flash your um, Google keys to everyone, right? So that they can use your Google. So we will not do that. This time, what we will do is we will ask for us to enter these API keys so that it is not visible to everyone and it has some security with that. All right. So we will import some libraries. So we will import OS. Okay. So that will be used for retrieving and learning files. And we will import this library called getPass. Okay. So this getPass will uh, it is generally used to get a password or a kind of like um, current username or whatever you want to be not visible. Okay, so we don't want our API key to be visible, so that's why we'll use this get pass, and this OS will uh, help us to call this function from the environment. So let's say that I am designing it um, on a on a cloud. Then what I will do is I will use a .env file, which is my environment file, and I will save this keys in my environment file, and then I will upload these environment file uh, to the backend, and I'm keeping that hidden, and I'm not showcasing this environment file to everyone, and we are keeping all these API keys hidden, and we are calling these API keys in our code. Okay, So we also need some libraries. So from LangGraph dot graph, we will import this state graph, which starts with capital S, and state S capital and G capital of this, and this end. Okay. So the state graph will keep in the state of the agent uh, in the memory, and this end is where my agent is ending. You can also import start, but let's skip that. We have this agent which works automatically. And from LangChain underscore Google Gen AI, which is here, so I will use that, and I will import this chat generative AI. Chat Google generative AI, sorry, chat Google generative AI to import this to chat with this Google's generative AI tool. Okay, so I have this Gemini model which I will use in this Gemini API, and I'm importing this chat Google generative AI to chat with the Google generative AI. So it says that Google AI is chat model integration. So you will have to have a Google API key, and you pass your API key, and you tell uh, which model do you want to use, and then you specify that model, and you can chat with this Google's generative AI tool, which is called Gemini, in natural language, right? Also, I will import from LangChain underscore core dot messages. I will import this human message. All right. So this human message is basically messages from a human. So whatever whoever passes this message, right? So there, this input, what we will pass is from a human, right? So I'm importing this human messages. So there are like different messages that we can pass in a LangChain and a LangGraph. So this human message is a message that comes from a user, right? So I'm importing that, and it always the LangChain and LangGraph know who is sending this message, right? And it is classifying that. So messages might also come from the large language model itself, right? So let's say that my LangGraph is dividing this input into three parts based on the query, right? So it is dividing it into um, these three queries using a router. It is saying that whatever the patient is experiencing, whether it is experiencing mental health problems, whether it is general problem or an emergency problem, right? So specify that. And these three outputs are not human messages. They are coming from the agent itself, right? So the large language model itself. So they are like agent messages. So we will specify that. We will specify human message, which are the human messages in this graph. Okay, so if you have imported all these libraries, just run this step and it will show you a green check mark if everything is fine. All right, so if you have made some spelling mistake, let's say S is small or G is small, then you will experience some errors. Okay, so you will have to check your spellings here. So we have imported, and we will now go to securing this API key input. Okay, so we will use these imports, and then step 1B of this is to secure this Gemini API. So let me just call it step B. All right. And to get this Gemini API key input, what we will do is we will go to this link ai.google.dev, which we already used in our first class. If you have your APIs with you, then no need to go here. If you don't have your APIs or you want to generate a new one, but you might have, right? Because we used it on our first day. So you have saved it on your notepad. So you can just go and get your API keys from there. All right. So what I will do is I will generate a new one so that the people, those who were not present on that time, they can generate this. So ai.google. I will just paste that link, ai.google.dev, and I'm copying this and pasting it on the chat box. Okay, so you can go to ai.google.dev. Those who are still typing in or those who are still importing these libraries, they can just get the code from here. All right, so we imported OS, we imported getPass, we imported langgraph.graph, we imported the state graph and the end. We imported this Google's Gen AI, and we imported this chat Google Generative AI to chat with this Google Generative AI. And from LangChain dot co underscore code dot messages, we import this human message, right? So just to classify it as a human message. All right, so next step is to secure the Gemini API key input. And I am seeing that a lot of people are sending me done messages because they are ready to move to the next step. All right, thank you so much, Shraddha and Kushal, for replying. And a lot of people, Sunny, Devi, Heli, Trushal, Preet, Kashish, thank you so much for replying so that we can move on to the next step. Artish also. All right. Uh, let's secure our Gemini's API key input. Okay, so what I will do is I will use this os dot ny run, which is saying that I take from the environment. So I said, right, so we will make this .env file, this environment file, and we can read this environment file from this OS library. And here I will type in Google underscore, let's keep it all caps, which is the best practice, underscore API, sorry, API underscore key. Okay, so I specified my Google's API key, and that will get this value from this get pass. That means that get password, get as a password, and I'm calling this get pass function from this, and I will say enter your Gemini API key. Okay, so basically I'm creating an input here which says enter your Gemini API key, and I will paste my Gemini API key on that, and it will save it as a Google underscore API key in the environment. Okay, as an environment file. So I will go to Gemini's developer ai.google.dev, and I will explore the models in Gemini. And what I will do is then click on this get API key. So if you are getting the window that I was getting, then you will just click on get API key, or you can just click on this get API key option from here. Okay, so click on this get API key and click on create API key. Okay, and it will, you will be able to create your API key in your existing project. So if you click here, you will have your my first project listed like this here. Okay, so I am also importing, creating this API key in this project, and what I will have is it will generate this API key, and I will just copy it from here. Okay, and I'll keep it copied, and I will just in my code run this cell and paste my API key here to save it. Okay, and press enter. All right, so I did not even have to show my Gemini's API key, and it already has stored this Gemini API key in my environment. All right, so I'm using this get pass method. So I got this API key by creating on this create API key here. If you are not seeing this kind of setup, then you would have something here which says that get API key, and then you click on API key. If you have your API keys with you, then use them. Okay, so you no need to create new API key again and again. All right, so if you have pasted your API key and ready with your API key, then just let me know by saying API key configured, or just say configure in the chat box. If you are facing any difficulty, let me know also. All right, Dave is saying not done, so I'm waiting for him. Gayatri is ready and configured. Mittal is saying configured. I don't know your first name. Done. Gayatri is API key configured. Nachiket is also ready for programming. Sakshi is ready, and Mahera is saying good to go. Chandan is saying done. All right, so let's work. So we have secured our Gemini API key input. So we are ready to use this Google API key because we have stored this Google API key in this environment variables. Okay, so these environment variables will be stored somewhere in the session. Now we will use Gemini's 1.5 Flash and we'll use their latest version to generate our response. Okay, we could have used any of the other versions, not the Pro version. So we'll use a 1.5 Flash, which gives some of the um, free generations for us. Okay, and we will call this as LLM. Okay, so we say that what is our LLM? Our LLM is this chat Google generative AI, and inside this I will specify my model. So my model is from models. I will add Gemini and 1.5 and Flash and latest. Okay, so latest Flash model, Gemini 1.5 Flash model, and I will set this temperature as zero point 0.2. So this temperature is the lower the temperature, the responses are uh, uh, the higher the temperature, the responses are more generic. The lower the temperature, the responses are more. So this basically is a spectrum of how much the LLM generalizes the responses. Okay, so we set this somewhere between the range of 0 to 1, 1 being the high temperature and 0 being the low one. So this is just to adjust. If your LLM is not behaving in the right way, you can just change these values in order to tweak your LLM to behave in a certain way. And you run this code. So so what we are doing in this step is we are making our LLM or the brain, right? So this brain will be this chat Google's generative AI chat model, and from this I choose this 1.5 Flash latest model, and I'm setting this temperature of 0.2. All right. So now, till now, what we were doing is we were just initializing our large language model or the brain. And we said that, okay, get this brain of our agent from this Google's API key, which is this Gemini API key. And we pass this Gemini API key into an OS environment, which we stored in our environment file, which we are not displaying to anyone. And that's the kind of best practice. And we installed all these dependencies here. Okay. And then step 3 is to design a node to ask user for symptoms. So now we are making this UI. Okay. So this is our user interface, and inside this user interface, what we will tell is we have an input box which says let's say what can we say, please enter your symptom, right? Please enter your symptom. Okay, and let's say welcome to XYZ hospital. Please enter your system. Please enter your symptom, or what is the problem that you are facing. Okay, so this is what we are displaying in our kiosk screen, and we are just doing a kind of like a simulation of this, not the whole implementation part of it. So we are just simulating it in this environment. So we say, welcome to XYZ hospital. Please enter your symptom. And that's kind of like a UI that we want to generate. Okay. So let's do that. So we will define this function called get symptom. Okay. And we will define the state of this graph, and it will take in a dictionary. Okay. And that's a dictionary. And why we are doing this is so basically we are defining the state of a graph that stores something, right? So we want to store this message, whatever message I got from this input, right? So let's say that I say, please welcome to XYZ hospital, please enter your symptom. And the user entered whatever symptom that they have. Let's say that they say, I have fever. Okay, so we are storing this in a dictionary way. Why we are storing it in a dictionary? So we are initializing a new empty dictionary here, and we are storing it in a dictionary because I am customizing this code according to Google Colab environment. All right. So in general, we don't store that as a dictionary. We store it as a state. Okay. So and we can define that state also. We can define those state as literals also. Let's say that we define three states, which are general, emergency, and medical health, and we define those states as literals. But right now, what I am doing is I'm not defining that state class. We can always define that, but here I'm directly taking this state, which is the initial state, from my user input. Okay. And here we just define what my state is. And my state is, let's take that input. Okay. So we call it as a symptom. So if a customer comes to me, I take this, I make this variable symptom, and I take input from my customer. I say, please enter. Where I say, welcome to XYZ hospital. XYZ hospital. Please enter your symptom. Okay. And I store this state symptom as symptom. Okay, so I say that, okay, there is a dictionary which I call as state, and I take this symptom from a user. I say that, welcome to XYZ hospital, please enter your symptom, and whatever the person enters, I initialize it as the input state, right? So my input state is in my input state symptom is whatever symptom that the person is having. Okay, so if a person is having fever, then I have fever. If he is writing here, then that is my initial state, which is the symptom, that the state that I will pass to the next step of this agent, right? And this function returns this state. Okay. So this is my first node. Okay, so I'm defining this node, which is my start node, and in this start node I'm taking this input and I'm storing it as a state, and I'm calling that state as symptom, and I'm returning that state from this input, from this function. Okay, and that is my node. So in LangGraphs, each node is a function. Each node I will define each node as a function. So this node is actually a get symptom node, right? So for the first step of my graph is to get the symptom from the user, right? So whatever symptom that they are having, so they are coming to my kiosk screen and they are typing in their symptom. This is the first step, right? And we defined it here. So we defined this get symptom graph, get symptom node, which is this, and the state is a dictionary, which is pointing to an empty dictionary, and then in this dictionary we are adding whatever input that the user is giving. Okay, I hope that's fine, right? Okay, so if you have defined your start node, then type in start node or defined in the chat box so that we are ready to move ahead with our next step. Okay, so we have done 2 steps till now, 3 steps till now, and the latest step that we did was defining the user, defining the state where a user enters his symptom. Arpit is saying that he has done. Trushal is saying configured. Still waiting for node. Pradeep is saying done. Sunny is saying ready to move ahead. And Devansh is saying done. Okay, so we are ready to move ahead. Okay. So this code can be, Uday is saying we can move to next step. Thank you so much for letting me know. Divyans is getting some error. Um, Module not found error, and he's getting it because uh, he has written LangChain E. So you have typed I after LangChain, and that's why you are getting that error. You can uh, change that. All right. So Preeti is saying start node. So this start node is where my okay. So he has defined the start node. All right. So he's saying that he has defined the start node, not asking me to define it again. All right. So I think that we are ready. We are good to go. Okay. So the second node of this is a router, right? So the second node is basically a router that routes this information to these categories, right? Sorry, which is emergency, whether the person has an emergency, whether the person is a general inquiry, or whether the person is a mental health issue. Okay, so whatever my symptom is, on the base of that, I will route them into emergency, general, or mental issue, right? And this decision will be made by a large language model, right? Okay, so we will go to step 4, which is we will make this router node to classify the symptom. And here we will use large language model as the brain to classify this symptom, right? So let's define that, and we call it as classify symptom node, right? So this router is also we'll call that as classify symptom. Okay, so we will define this classify symptom node, and each node is basically a function only, right? So in this classify symptom node, I will pass this state, okay, whatever state I have, right? And which will point to a dictionary. So this I'm saving all these states in a dictionary, and I am using this state function to pass this parameter state, right? So it's not a function but state parameter that I will pass. So यहाँ से मुझे जो भी input मिलेगा, welcome to XYZ hospital, please enter your symptom, यहाँ पे जो भी symptom enter करेंगे मैं उसको इस function में pass कराऊंगा, right? So from first node I will pass this function into second node, and I configure my prompt. Okay. So here we will use our prompt engineering principles. Okay. So I will pass in a prompt. So this prompt will take in whatever state that we have, and we will use prompt engineering here. We already have learned prompt engineering, so we will use all the principles of prompt engineering. Okay. So first principle of prompt engineering is to give a persona. So we'll say you are a helpful medical assistant. Okay. And then I will give the direction, right? So I say classify the symptoms below into one of the categories, right? And I go to a next line in just to beautify it, and I write general. Okay. Emergency, emergency, and medical health, mental health. Okay, so classify this into general, emergency, and I want them in next line, not with comma. So let's say that mm, So I'm just giving it a structure. So I'm saying that you are a helpful medical assistant. Classify symptoms below into one of the categories: general, emergency, or mental health. And I use this f string literal to parse in some variable, right? So I say my symptom is, and I use this state to get this symptom. Okay. And backslash. Next line. So I say that you are a helpful medical assistant, which is defining a persona, give a direction, classify the symptom below into one of the categories, uh, general, emergency, or mental health. So if I say that, okay, mental issue, we can write mental health also, or whatever, right? So if it is a general category of symptom, then I will use general. If it is an emergency, then emergency. If it is a mental health, then mental health, right? And then I will specify the format. I say reply or respond with only one word. Okay, and I give the word general, emergency, or mental health. Okay, I say I respond only with one word: general, emergency, or mental health. So you are a helpful medical assistant. Classify the symptoms into category general, emergency, or mental health. And then symptoms are these, right? So I can also give them example just to train. I have fever. Output is um, input is I have fever. Output is general. Okay, I say that if my input is I have fever, then my output is general. This is then I will fine tune it with more examples. If it is not behaving right, I will fine tune it with more examples, right? So I say you are a helpful medical assistant. Classify the symptom below into one of the categories and general, emergency, and mental health. And then symptoms of it, I get from this input, which are the symptom, and then respond with only one word, which is general, emergency, and mental health. And I have these examples that you learn from these examples, right? And on the base of this prompt, I will generate a response. Okay, so I will store that in response. I say LLM dot invoke, and I invoke this human message, and the content of this message is prompt. Okay, so I'm storing this. So I'm invoking this large language model. I'm saying that invoke this large language model, whatever generative AI model we are using, and invoke this on this message which I am getting from input. So this is the input, and I'm getting this message from the input. Invoke this message, which is a human message, because I have categorized it as a human. Because this input is a human message, and my content is this prompt which I defined here. Okay, so I'm storing this in a response. So जो भी response आएगा, so response will be general, emergency, or medical health, any three of them. Okay, and I store this in another variable which is category, and I store this response dot content dot strip. All right. So I'm using it as a string of characters. So this strip method, what it does is it returns a string of these characters. So whatever the output will be, it will change it into a string of characters. And I also print this. So let's say I'm using f string literals, and I say LLM classifies the symptom as, and I use, sorry, this category, parse this category variable. So this is just to debug. Okay, if there will be any errors, then I will check if the LLM is categorizing it or not. So I'm saying that, okay, print this LLM classifies the symptom as whatever symptom is there. Okay, just to see if it is working or not. And then I update the state, right? So now the state of the graph will I will add in one more state which I will call as category. Okay. And in this category state, which is a dictionary, I will store this category variable. Okay. So my state will look like this. My state will have a symptom as the key, and inside that value will be there, whatever the user inputs. And my state dictionary will have category as the key, and it will have whatever category this large language model is categorizing it as the value in inside that key. Okay. All right. So if you have the node to classify the symptom, just press this and also run this cell. Okay, so note to you ask you. So if you have the router, so we will call this as route the classifier of the router. So just type in router done or classifier done or something like that in the chat so that I know to move ahead. Right. Okay. So one more step that this classify symptom node which we have right now here, what will this function return, right? So this function will then return a state, right? Why it will return a state? Because so whatever the state will be there inside this category which we store, it will return it here, right? So this function, this classify symptom, will return a state um, which will now have this key category which we can invoke this state from, and which have the value of this category. So emergency, general, or mental issue, whatever the values that we get, we will have that as the category. Okay. So return state is also what you need to put. So if you have missed that, please put that also. So this function returns a state. And thank you so much, Divyansh, for also reminding me that I have to return the state. I have added that now. Uh, Zeal is saying defined. Uh, Bhargav is saying router done. Thank you so much. Neil is saying done. Prashant is also ready. Rajan is also saying done. If you are experiencing any difficulty, let me know. Meet will say configured. Aman is saying classifier is defined. Khushi is saying not done. Okay, so I will just wait for Khushi also to complete this. Aditya is saying classifier done. Khushi is still doing it. Param is saying he's getting an import error. Okay. Yes, so you will have to use this. Um, so you just typed pip. You also had to type this apostrophe. No, sorry, this exclamatory mark. So in like local environment, you will just use pip. In collab, you will have to put this apostrophe also. So not exclamatory mark also behind pip. That's why you are getting this error. And Daksh is saying step 4 done. All right. So step 4 is done. 4 more to go and our agent will be ready, right? Okay. So step 5 is we will use this router logic to route to the correct node, right? So we say that, okay, we will make a router. We classified this symptom and we will make this router logic to route this to the proper node. So if the symptom is general, then we will route it to a general node. If it is emergency, we will route it to emergency. If it's a mental issue, then we will route it to a mental issue. Okay. So router logic to route to the correct node, and let's do that. So we will define our router. Okay. So we say that as router. And in that we will pass this state. So let's say that medical router, or we say that try, or let's say router only. We could have used any other variable. We could have said that it is routing into three, or three state router, or symptom router, or something like that. But let's name it router, or let's name it symptom router. Why to confuse? So if we have like more routers, then we can define them more in a more better way. So we say that this is a symptom router. It takes in state, right? So this state will again be a dictionary, and it points to a dictionary, and we define this symptom router. Okay. And we say that we make a variable which is category. We call it cat because we already have a variable category. I don't want to mix it up with this. So we say this variable as cat. And in this, I will store this state, whatever the state of the category. I will use this category key in the dictionary to get the value of the category from the previous state, right? So जहाँ classify sim जब उसने classify किया तो sorry, there is one more step in between. I forgot to introduce that this classify symptom will be a node. Okay, it's in itself. And do this. Okay, so this is also a node. This is classify symptom node in which I am uh, using a large language model to classify it. Okay, it's not a router yet. Router is what we are designing now. So after classifying the symptom, so this is a large language model. I am so sorry that I mixed this up. This classify symptom will just classify. It will not route, right? क्योंकि वहां पे हमने route का logic तो दिया ही नहीं. हमने बस बोला classify कर दे. So this is just a large language model, and now we will route it up, and that's what we will make, right? Loud router. So हमने relay में भी ऐसा ही किया था, right? We classified it using a large language model, and then we made a if else statement वाला router. So I am taking this state, this category, the state, whatever category is there, and I call that variable as cat, and I'm taking everything in lower. Why I'm taking everything in lower? Because large language model का output कुछ भी हो सकता है, right? वो अगर मुझे बोले जनरल करके दे दे तो G कैपिटल होगा तो या फिर स्मॉल में भी देगा, स्मॉल G देगा. So we want everything to parse, right? So that's why we are keeping this category of this as lower. And now we define our router. So we say if general in cat, okay, so return general. Okay, so I am saying that if there is general in cat, then return general. So I am just making a router which will uh, return certain values, and um, it is basically routing. So if I say that it is routing into different um, branches, right? So if my category is general, then return general. If it is emergency in cat, okay, so return emergency. Okay, so all should be small. Why? Because I am taking everything in lower. Okay, so if emergency in cat, then return emergency, and just check this indentation. Okay, so this will automatically take you to um, when you press enter here, so it will take you here, but the indentation should be just parallel to if. Okay, so we are using this nested if else statement, and else if mental. Okay, in cat, because it will just return with only one word. We had configured it for mental, right? So return mental health. So else return जनरल, सो वी आर डिफाइनिंग कि अगर कुछ भी नहीं है तो जनरल वर्ड में भेज दे, ठीक है. एंड सी वी कुड हैव, व्हाई वी आर डूइंग दिस, यू आर सेइंग सर input is coming from here, why can't we just use that input to route, right? So that input might have certain values, so we could have said return 1 if the if the symptom is general, return 2 if the symptom is emergency, return 3 if the symptom is mental health, and we could have given examples to train it, and it would have returned 1, 2, or 3. And then here in the router we could say that if 1 in category, then return general. Okay, so we can make these branches define in my router in which state of, or in which direction my agent should route these values to. We can define these branches, okay, or steps. So this router is very good in, so we need to define a router which routes this in a proper way. So I say that here I got mental in category, right? But mental is not my category. My category is mental health or mental issue, let's say, right? So अभी इस example में we are using issue, so we will take that only. So mental issue. Okay, so I am saying if mental is in category, then return this mental issue. Okay, so this is defining which way I should go. All right, so if you are configured with step 5, we have just 3 steps to go. Let me know in the chat boxes if you are experiencing any difficulty. Uh, and Kushi is saying that in your error, it is showing that it could not find a version. I think you should have specified this as 0.8.5 and 0.6.15 only. Otherwise, it will give you an error. Okay, so define it as that. There should be an there will be an error somewhere in this. Okay, so I am showing step 4 and step 5 only specifically in my screen right now. And let me know if you are also following. Shraddha is saying, sir, why we have to declare input as a state? You can declare input as a state also, so that you can start with an input state. There can be multiple input states also in a multi-agent system, and that is just to invoke the agent, right? Okay, thank you, Shraddha, for saying router logic done. Okay, so we are ready for the next step. Kushi is saying that she wrote exact same, still getting error. There will be some error in, maybe you skip this QU part here. If you would have written same, then I am also using collab only, right? So it should have been giving error to me also. Uh, it is what, when I wrote it without these versions, it was giving errors because the latest version doesn't support these Google's Gen AI as LangChains. And Dhruvi is saying router done, and Kushal is saying done, and Vishal is saying into return emergency missing parenthesis. Yes, thank you so much for reminding me. I should have put parenthesis here, right? So uh, that's what happens in live coding. Sometimes you forget things. And Dhruvi is saying in step 5 there is uh, yes, here. If I would have run this, I would have got a error. So why error? Because this should be passed as a function and not as a string, right? So parameter is always passed in these brackets. Thank you so much, Dhruvi, for reminding me, and I will not get an error. So always run the code before you, after you write it, so that if any errors are there, you can remove that. All right, because we have been writing state as a square brackets. That's why I got confused in this, and but that's fine. Vishal is saying step 5 done. All right, let's move to step 6. Okay. And a lot of people saying all done. Atish is saying successfully run. Okay, so let's move to step 6, which is we are going to define category specific response nodes, right? So if my category is general, what should I respond to? If my category is emergency, what should I respond to? If my category is mental issue, what should I respond to? I will define it here. All right, so let's define all these functions. Okay, so now from this, I will go to these nodes. Okay, so this router will go to emergency node, to general node, and to mental health issue node. Okay, so we will define each node. So we will define this general node. Let's start with general node first. Okay, and we pass the state as a dictionary, and which will inherit, which will point to a dictionary, and I will take the answer. Okay, so I will store an answer in this state, and I will say in the f string literals, I'll say, let's say, uh, state and whatever symptom the person is having, symptom PTOM, get the symptom of the person, and just say, uh, so if a person says that it's a general symptom, so if a person says I have fever, then return that, okay, what is the symptom? Is this I am adding just to add a debug thing, so that if my state is symptom is being passed here, and I say that seems general, uh, um, directing you to general ward. Okay, so right now I'm not writing the logic for directing to general ward. Okay, so and what is the type of form that he has to fill or whatever. I'm just saying that directing you to general ward, or for consulting a doctor. Okay, so I am saying this is what we will do after this. This you will have to build on your own, whatever in your project that you will build, right? So I will also explain the problem statements. This you will build in your projects. So I say that if my answer is general, okay, so in if I go to this general node, after this your agent should direct it to a general ward, or directly consult it with a doctor. Let's say it sets up a video call to the doctor, or sets up an appointment with a doctor, or let's say it just gives a screen in which to fill user details, and then give a ticket after printing to the user and saying that okay, now you can consult the doctor at a particular time. And then it also, after this, what it can also do is it can this route can um do certain things, that parallelly it can also send a message to a doctor that appointment has been fixed. It can also print your receipt that the appointment has been made. It can also point you um, to a payment system where you can pay and book the appointment. So after this we will define the node, but today in this class we will not be able to, because we are running out of time. So but this logic you will have to define in your agents that you are designing. Okay, so if you defined this general node which will return this state, and you return this state, so the state is now a answer, which I'm saying that okay, seems general, directing you to general ward for consulting a doctor. Whatever symptom is there, you are saying that it is a general symptom. Okay, and I add a system symptom like this. Okay, let's define our emergency node. Okay, so we say that, okay, if the person is having emergency, then what to do? And this is a dictionary which points to a dictionary, and then I define this emergency node. It takes in it it updates its state, and I'm adding a key which is answer to this. I will just copy this from here. Command C and Command V, and I say that it's a medical emergency and seeking immediate help. Okay, so I'm saying that, okay, it's an emergency and I'm seeking immediate help, and then maybe route the patient to the emergency ward or something like that, or maybe give a form for emergency ward so that they can make a uh, payment there. And then you define this mental health issue. So you say mental health node, and you parse in that state, which will point to a dictionary. And inside this dictionary, again, I am pasting the same thing. I am saying that whatever symptom is it, seems um, it might be related to mental health. Uh, Book or talk to our counselor. ओके, एक्सपर्ट भी बोल सकते हैं उसको. All right, so I've defined these three nodes: general node, emergency node, and mental health, mental issue node. So I say that this router is classifying into emergency, general, and mental. And here I am not defining logic after this. You can define it later. So after, in this general node, you can define what happens in this general node, and maybe it is a router, maybe it is a classifier, maybe it is just calling some form, or maybe it is sending a WhatsApp message to the doctor. Whatever things that you can do in this node, you can just define it here. And you can use large language models like ChatGPT or GitHub Copilot or any other tool to code, and you can just ask that, okay, this is my general node, this is what it does. Now write me a code to do this. All right. Okay, so if you have defined all the three category specific response nodes, let me know in the chat box. Gayatri is saying that she has configured, done. Dev is saying that he is having some issues on API key step. Okay, he has resolved these issues with AI, which is the world that we are living in, and that makes our coding very easy. And Nachiket is saying ready to move further. Sakshi is saying that she's good to go. Maybe we can keep up a little bit pace because we are a little bit behind. Okay, configured all nodes. Toy is saying. Okay. So if we have configured all nodes, so all nodes are done now. So emergency is done, general is done, mental issue is done. Now we will build our LangGraph. Okay, and it's very easy. So we will connect our LangGraph. We will build it up. And for that, we will call this builder class, and we'll say it as a builder, and it will take this state graph class as instance, and it will take in a dictionary, right? So I'm basically making an instance or a um, object of the state. If you are into object oriented programming, then you will know um, how it works, right? So we are basically, I'm making an object. I am seeing an error that it says return state. I think I have an indentation error. So I have an indentation error here. Okay, so just remove it. Say okay. Mm. Still it's giving me an error. It says that it is unmatched. Where is it? Not matching. Okay, I'm doing everything right. Mm. in this general directing for you to. I think I'm using okay, I can use a single bracket here. I think that will solve the problem because I'm using double brackets outside. And let me run it. Again, it has an unexpected indent. I think I should just do a yeah, fine. So why? Because I could not use it. Use double apostrophes inside. If I add double apostrophe, I will have to use single apostrophe inside to define everything. That's kind of like a syntax error in Python. And I think that we are done. If you are experiencing similar kind of errors, then you can just remove those double apostrophes and all. So we'll start building our graph. So we'll start calling it a builder, which will inherit this state graph, and it will take in a dictionary, right? Which is our state dictionary. And I will set a entry point. Okay, set an entry point. I'll set an entry point, which I will call as get symptom. Okay. In this graph, which is a dictionary, I'm basically assigning these nodes. So my entry point is this get symptom node, right? So which is my first node. Okay. And I will define this node. I will add a node. I'll call it add node. And I will say that this node is get symptom node. And the value of this node is get symptom, which is my first function, right? So this get symptom function is what my value of this get symptom get symptom node, and I am defining the name of this node as get symptom, which is my first node, and I'm adding this to my graph. Okay, so in my graph I'm noding this, adding this get symptom node, and I'm saying that this get symptom node, what it does is that it this function get symptom which we defined, right? So I this is the name of this node, and this is the node. Okay, and then I will add another node. I will add all these nodes now. Okay, so I will add get symptom node, and the next node is classify symptom node, right? So I call this as classify, and this will take classify symptom, classify symptom as a function. Okay, so this node is a is actually a classify symptom function. Okay, so second node is a classifier, so I call it as classify, and I add this node. Okay, so I'm adding all these nodes to this graph now. So this state graph, which the lang graph has, what I'm adding is I'm defining all of this graph. So I said my entry point is this get symptom, which is my get symptom function. Second node is classify node, which is my classify symptom function. Third node is router. Okay, so no, sorry. Third node is my general node. Router is not a road, right? So general, emergency, and mental issue. So my general node, which is my general node, okay, and builder dot add node, this emergency node, which is my emergency node, and my mental health node. Sorry. Just copy paste if you are feeling lazy. Mental health and mental health node, right? So you will have to define this as function. This is not a value. And okay, so I have added all nodes, right? So I said add one node, which is get symptom, which is this function, add classify node, which is my classify function, add general node, which is my general function, add emergency node, which is my emergency function, and mental health node, which is my mental health node, right? Okay, now I will add edges. Okay, so these nodes are there. Now I will add these edges, or these branches, which we call, but here we call them edges. So first node, my get symptom node, will have this edge, right? So this edge to classify symptom node. So I will add that. So I will say builder dot add edge. Okay, so I am defining this graph. So from my input node, which is the start node, get symptom node, my edge will go to classify symptom node, right? So I say from get symptom, sorry, I will have to put this. Okay, don't add a space to it. Get symptom, I go to classify node. Okay, so I say from get symptom, I go to classify node, right? And builder dot add edge. Uh, so this edge, the next edge, this router edge will be a conditional edge, right? So this will not be a normal edge. So this is a normal edge. After this, I am going to this. After classification, I am going to this router. So this router basically in past LangGraph, it was called a router, and we used to use a router to route it. But now it's changed, and it is called a conditional edge. Okay, so I am adding a conditional edge, which I call as router conditional edges, and it will go from this classify node to this router, right, which we called as, what did we call it? We call it as a symptom router, right? So symptom, this is here. So this conditional edge, I'm going from this classify node to a symptom router, right? Why conditional, not consistent? And from this classify node, I go to this symptom router, and from this symptom router, I need to go to these nodes. Okay, if my category is general, then I go to general node. Okay, if it is emergency, then I go to emergency node, and if it is mental health, then I go to mental health node. Okay, sorry. So this conditional edge, what it will do is it will take the input from classify node, and whatever is the classify, it will use the symptom router function to return whatever is the um, whatever is the c- classification or category, and on the base of category, it is adding these branches. So or these edges. Okay, so these conditional edges, three conditional edges. General as a conditional edge if general is the output of classify, emergency if the classify is giving emergency as output, and mental health if mental health is the output of this symptom router. Okay. Okay. And finally, what I will define is, I'll also have to close this, and I will define my end. Okay. So after this, I'm defining the end. So after going to emergency, general, mental health, I am just going to end my graph. So there can be many things after this. You can add more conditional edges. You can add define more things inside this graph, and you can make it more complex as you go. But right now we are making it very simple. So I am adding the edge which goes from general node to end. So after saying that go to a general word, I am just ending it, the logic there. And I am adding this edge from emergency to also end, and add edge, and finally mental health to end. Okay. So basically what we are doing is after this, we are not defining this. This you can define in your project. Okay. So this is for project work. Here what we are doing is after whatever happens in this emergency, um, general and mental health issue node, we are ending this graph. Okay. Here. Maybe I could not make it right, but I'll just type in end here. All right, so I have my entry point as get symptom, and from get symptom, I'm going to this classify node. And from I'm defining my nodes first: get symptom node, which is my get symptom function; classify, which is my classify function; general, which is my general node function; emergency, which is my emergency node function; mental health, which is my mental health node function. I'm building an edge from each node. So my start node goes to this classify symptom node. So get symptom node goes to classify, and I'm from classify I need to have a conditional edge because it is checking the condition. If it is general, then go to this general node. If it is emergency, it go to this emergency node. If it is mental health, then go to this mental health node, which I defined here. And then again build a edge from general and emergency and mental issue to end. All right, so just let's completely finish it. Our last and final step. We are going to compile and invoke this graph. All right. If you run this, you will return with a LangGraph. Okay. I am experiencing a syntax error, which is on line 14. Okay, I think that I need to just remove the space. Mental health. Oh yeah, comma here. And some more errors, which is I did not define this in proper way. I added a space. Some more errors, which is missing one required positional argument, which is the key. I think I have defined it. And I think I have, that's right. I'm defining this key only here. This get symptom is key. Maybe my get symptom, no, my get symptom function is fine. It returns this dictionary. All right, maybe I can use AI to this. I will just say explain this error. And all right, so it says, yeah, so I accept it. And now I get more error. I think I don't need to do that. I'll just revert it back. Oh yes, here. Again, because I'm typing these dictionaries again and again, I'm just typing these dictionaries. Whenever I hear a word dictionary, I just type it in like rectangular brackets, and that's why the error is there. Right. So so I visualize dictionaries as sometimes I visualize them as strings, sometimes I visualize them, although it should be a curly bracket, but then again, like I don't know why I keep doing this error. So if you are also experiencing the same error, you can just remove that and you'll be good to go. And it returns a LangGraph.graph, which is a state graph, and you can also see that graph. Okay, so you can just type in graph and you'll be able to see that graph. But you will also need to compile it before. So let's compile it and then invoke this graph. So to compile and invoke the graph, we will need to use the compile function, and we will call that as graph. And we say graph equals builder dot compile. Okay, so we compile this graph and we call this graph. Let's see. Okay. H ending at unknown. No unknown node get symptom. Somewhere there is an unknown node which is get symptom, which is uh here. Sorry. And yes, and then I compile this graph and I call this graph to see how it looks like. Okay, so we can't call this graph directly. There is a function that we can call it from, but uh, so I compile this graph builder.compile, and this graph is being is being compiled, and I add a final state, which is I will invoke this graph. Okay, so I will invoke this graph by calling this invoke function, and that whole graph would be invoked, and I'm parsing in an empty dictionary inside. And I print the final output, which is final output, and I print this final state, and I call answer from this final state, right? So I have defined somewhere answer, which is here, and I'm calling this answer in my final state. And this final state is when I invoke this graph, what is the what is the what is the final state that we have. So if I just parse this, then it calls this it invokes this graph, and I invoke this graph. I say that please enter your symptom. So I say I have high fever, and I press enter, and it says LLM classifies the symptom as emergency, but after this uh, uh, there is a key error somewhere, which is category, and this key error is here, right? So I have said this as capital C, and maybe I will have to type in capital C only here. So okay, so my symptom is I have fever, let's say. Okay, so I don't type I have high fever. So for fever, it is classifying it as general. So it is classifying properly, but now my output is not coming because I have some syntax error somewhere. Not the right parsing error. So I think inside my general node, uh, my category is, yeah, category is general. Okay. State is category, and I am parsing this as category. And what is the error that I'm getting? Again, maybe I did not run this. Okay, I will have to run the whole graph. And I'll have to put in my API keys, which I have forgot. So I will have to generate new. And I create one in this. I copy this, pass inside, press enter, and I say I have fever. It gives me, it categorizes this as general, but still somewhere it is, uh, it is saying some type error, argument of type built-in function or method is not iterable. Mm, if general and category. All right. And return general, which is fine. Mhm. L if it's an emergency, return emergency. I think the issue is correct here. Hmm. Yeah, I need to invoke this function. I think because of the lower case setting, I guess if I write, I have fever now. Okay. Okay, it is raising this resource exhausted um thing because I think I have exhausted my keys. I will go to another account and make a key. Okay, Google AI dot something like that. Google AI, Google API. I want to. I'll just paste the same link here. All right, so copy this from here and I will just paste it here to get my new API keys. Just it will take just 5 more minutes and then we are good to go. I think you will not be having this error. I am having it because I might have used my free plan too much because I've been teaching for a long time and I've taken parallel sessions with this also. So if you run out with a issue like this, then what you can do is you can always create new API key um, in any other account if you are doing it for learning, right? So always uh, you can use this free API keys if you are doing learning. Otherwise, you can use the large language model like ChatGPT if you want to. Um, wait, I think I will have to invoke this first. Run all. Wait, it's waiting for this. And I say run all. And I paste my API key here. Press enter. It says enter your symptom, and I say I have fever, and it returns this. Okay, so it says that I have fever, seems general, directing you to general ward for consulting a doctor. Let's say that I say I have high fever. Then it says it's a medical emergency, seek immediate help. And if I say I am depressed, then it says, okay, now my resource is exhausted. Um, it should not be giving this error. So it says that there is an issue somewhere. Um, so it classifies it as mental health, and then there's a key error in here, which is a mental issue. I should have wrote health, and somewhere I have written mental issue as a mental health, right? Yeah, here it should return with mental health, not issue. All right. So if you know your code, no matter you write it with large language model or you write it yourself, if you know your code, then you always will be able to get the answer, right? So if you say I am depressed, then I am depressed might be related to mental health. Talk to an expert counselor, and then you can build your graph more complex. So a very easy uh, classifier or a very easy graph we made, a real-time challenge or the real-time problem that we are solving. How to make UI and UX of it, you can always make, but this is what the brain of the system will be. So to deploy this, you might be using some front end which you will make in Node React JS, and then you will be using this as backend, and you will be using fast API to call this backend from the front end, and then doing everything in this backend, and then returning all that answer to the front end. All right, that brings me to end of today's class. Thank you so much for if you are facing any difficulty, I think that there might be some issues with um, the uppercase and lowercase, and nothing else was more error. I also specified mental issue in here. It should be mental health. So if you have configured like me, you will also have to do the necessary steps to remove the error. All right, so we are already past 15 minutes from this. I will quickly let you know what will be our although I have like one more class tomorrow, but I will quickly let you know what will be our project that you have to define and design. So if you are done with the code, just let me know in the chat box with a done or yes or something like that. Thank you, Chandan, for saying done. If you are experiencing any errors, then also let me know so that I can explain the project to you. Okay. It will just take 5 minutes to explain the project, and then I will explain it in a better way tomorrow. But you will start working, right? So that you don't waste much time. You are also experiencing key errors like category. So you will have to like change your category, whatever is there, from capitals to small. Okay. And all right, so quick projects that we are going to design is we have these SDGs. Okay, so SDGs are Sustainable Development Goals. These are some problem statements by United Nations, and I'll just remove the annotations. So there are 17 sustainable development goals. That means that there are 17 goals that United Nations, or 17 problems that United Nations identifies. First being no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation. You can just type SDG in Google and you will be redirected to this site. Okay, so you can see that there are 17 major problems that United Nations define as problem statements. By 2030 they want to eliminate all these 30 problems, all these 17 problems. Okay, so you pick one problem out of these 17 SDGs. So let's say that you pick poverty as a issue or zero hunger as a issue. Okay, so for this zero hunger you are designing a agent. Let's say um you can design any agent in a restaurant. Let's say that you are designing an agent where you want to just donate some food to someone. I don't know what the problem can be. So you define a problem and then you design a solution to that problem, which I will explain tomorrow because I don't have much time. That's why I'm not able to explain it properly. What can be a good agent is, let's say in climate action, you want to design an agent that classifies um, a waste into green waste, into wet waste and dry waste, and after that it sends a notification to let's say um, you design a kiosk screen where you are depositing your waste, and then it is uh, d- classifying that waste into wet and dry, and then it is calling the required authorities to get that waste, right? So, or maybe in medical, the kind of good health and well-being, you can design a agent just like today, which is enabling these hospitals to provide faster health solutions. Maybe for quality education, you can design a chatbot kind of agent which understands how the user is learning and then provides them different kind of learning platforms or opportunity. So let's say that I am a student and I am asking some question to the agent, and the agent is understanding what kind of question that I am asking, whether it should give a emotional response, whether it should give a logical response, whether it should give a knowledge response to that question, and then that question is being said. So you can define your states, you can define your graph. More about this I will talk in tomorrow's class, but for today what you can do is you can just check these SDGs, define one, pick one SDG, define a problem, identify a problem, define that problem, and design a solution to this. A full exercise we will do tomorrow, where we will also have a lean canvas. So we will fill a lean canvas to identify a problem and design a solution to that problem. But that will be a big exercise. Right now I can only explain it in small simple way, that out of these 17 SDGs you will have to pick one to design your project on. So start picking the problem that resonates with you most, and let's start building our solutions to that. All right, that's all from my end, and I hope that you have been able to design the agent, and you had a fruitful session today. And that's kind of like the agents that we can build with open source. We don't need Relay for that. Relay was drag and drop. Um, uh, and thank you so much for your messages. Some of them are getting errors. You will have to just see in your code where the error is. Instead of square brackets, there will be sometimes open brackets instead of commas. Somewhere I will add some, you will have to add some comma, but apart from that, there should not be any error. All right, thank you so much for those who attended today's class, and thank you so much for those who let me know in the message box what errors that I was occurring, so that I could identify those errors. Um, if you have questions, I am here. Otherwise, my team will just float attendance link in the chat box, and you will be able to file your out attendance for today. Over to you, team.
Okay, so thank you so much, Amit, for today's session. I will quickly share some of the important announcements before we wrap up today's session. So, yeah. This is the consolidated certificate which we are asking you to upload on the Drive link, which says from learner to builder become an AI agent. This is the only certificate when this consolidated certificate when you complete the three courses which has been I am being explaining you throughout all the master classes. This is the consolidated certificate we need you to upload as a deliverable one. This is sponsoring organization screenshot wherein like we need you to attach the screenshot which says Shri Mahakal Education and Charitable Trust Rajkot, which shows their sponsoring organization. There are some of the students whose sponsoring organization is Open Skills Bill Educate Foundation or CSR Box. Don't worry, please attach that screenshot as well. Also, if you could just quickly take out your mobile phones and scan this QR code. This is your attendance, just to mark your today's attendance. My teammate is also sharing the link of the attendance on the chat box and on the WhatsApp as well for the students, those who have joined live on YouTube. Also, we have one resources and recordings document wherein we have dumped all the master classes recordings, all the decks of the recording. If someone has missed their master classes in case of any medical emergency or any personal emergency, they can, get a hang of this Word document. We have uploaded till date four masterclasses, three masterclasses, and fourth one will be uploading the recording of the masterclasses by today end of the day. It will going to take some time to reload. This is the link of your attendance sheet. My teammate Anil is also putting down the link of your attendance sheet on your chat boxes and on your WhatsApp as well. Apart from this link, he is also putting down one link of resources and recordings document in which we have put down how you can download your certificate, what is which link you need to click in order to get three certificates of your learning plan. There are total three self-learning modules. In order to complete that, you will receive this type of a certificate, which we will be asking you to upload onto the final form one, which says from learner to builder, become an AI agent architect. And also you can download the consolidated certificate from Credly. How you can download that certificate, we have been also uploaded the video on the resources and recordings document. Please go through that document thoroughly. If anyone of you have missed the master classes, you can definitely watch the recorded session of the of that particular master class. I will quickly share my screen in which I will be showing you the resources and document link. Just hold on. Okay, so this is the resources and document link which I am talking about, wherein we have jot down and put down all the self-learning modules, all the video tutorials, self-learning plan. If you will click on this link, you will redirect it to the page which will ask you to do three self-learning courses in order to get the consolidated certificate. So yeah, when I will click on my self-learning module, this will redirect to you to this page which says from learner to builder, become an AI agent architect. When you will scroll down, they'll ask you to complete all these three courses, which is getting started with artificial intelligence, and unleashing the power of AI agents, and the rise of multi-agent systems. These three courses are mandatory for everyone to do in order to get one consolidated certificate. And also, we are asking you to upload the screenshot of your sponsoring organization. If you scroll down on this document, you will find many tutorials we have uploaded, that how you can sign up onto the platform for the students, those who have joined the internship from mid. They can see this video, they can sign up on the platform, and they can complete the course. How you can download your certificate, how you can check your sponsoring organization, how to download your certificate using Credly account. You just need to click on this link, and this will redirect to you to the video orientation session. Everything, the decks and the recordings have been uploaded here. Okay, this is the attendance for today's session. Last 1 minute and we will be wrapping up this session. Your next, I mean, last masterclass is scheduled tomorrow. We will be sending you the Zoom link on your WhatsApp. For that, please be active on your WhatsApp groups. Okay, I can see many of the students have just punched in your attendance. So, yeah, good evening, everyone, and see you, everyone, in the last masterclass, which is scheduled tomorrow. Bye, everyone, and have a good day. Bye. Bye, Amit. Bye.